Today, we're going to talk about the introduction to marine mammal stranding networks. My name is Gabriela Hernández Mora, and I'm the head of the Veterinary Microbiology Unit at SENASA Costa Rica. This presentation was also in cooperation with information of Claire Pusineri. Here, we're going to talk about what is a stranding network, why set up a stranding network, what data and samples can be collected, a long-term and wide-scale project, tips to develop a stranding network. First, what is a stranding network? We're going to start with the definition of a stranding. A stranded marine mammal is essentially one that appears in distress, is faltering ashore, or is a carcass. In the US, a stranded marine mammal is any dead marine mammal on a beach or floating near shore, any live cetacean on a beach, or in water so shallow that it is unable to free itself and resume normal activity. There are three main types of strandings. Individual strandings, which concerns isolated individuals. Multiple strandings, which concern a large number of individuals which may belong to several species, found stranded over a short period of time, a few days to a few weeks, and located in a restricted geographical area. Mass stranded, which is a simultaneous stranding of several cetaceans belonging to the same species and the same social unit. It mainly concerns gregarious odontocyte species such as melonhead whales or pilot whales. In most places, most stranded animals are dead. In French Caribbean, since 2010, among 68 recorded strandings, only 7 involve alive animals. Stranding networks may also have to deal with animals at the sea, both dead and alive, but in distress. Distressed animals are often trapped in a coastal infrastructure or entanglement in marine debris, such as fishing gears. The causes of stranding are multiple, but three main categories can be distinguished. First, natural causes, including malnutrition, disease, trauma, predation, maternal separation, poor navigation due to weather or other conditions, and exposure to biotoxins. Anthropogenic causes include bycatch and entanglements, which are the primary cause of stranding in many regions of the world. Vessel strikes, exposure to noise, oil spill, or ingestion of plastics. And finally, environmental causes, climate change, storm, algal toxins, and earthquakes. What is a stranding network? A stranding network brings together scientists and volunteers and coordinates their response when an animal is found stranded on the coast or distressed at the sea. The goals of stranding networks are to provide care to alive animals, maximize data and sample collection from all animals, and share data through conferences, publications, and reporting. The stranding response combined welfare, science, and conservation priorities, resulting in human response to live stranded marine mammals and quality data collection. Analysis that inform conservation and management strategies. And here is a summary of the stranding response overview. When we have stranded animals, we have three scenarios. First, if the animal is alive, stranded on shore. Second, alive in near shore. And third, if the animal is dead. If the animal is alive, stranded on shore, we need to assess the animal condition and field conditions. We can refloat, we can rehabilitation, or we can apply euthanasia. If we decide for refloat, the individual must be able to stand alone. We need to make monitoring, keep the public at a distance, monitor location and behavior at the surface, and public engagement may be mobilized. If we decide for rehabilitation, we need specific logistic equipment and resources are needed. We can make first aid, assessment of vital signs, evaluate the stranding costs, we need transportation, a time to recovery, and then release. If we decide for euthanasia, this decision is taken when there are no available options to improve the quality of life of the individual. The procedure must be implemented in the absence of the public and, if needed, resources, expertise, and material are available. If the animal is alive in the near shore, we need to monitoring, keep the public at a distance, monitor location and behavior at the surface. We need public engagement, may be mobilized. If the animal is dead, we need to assess the decomposition state. We need to collect data and samples. We need to use standard protocols, be mindful of biosafety, specific logistic, equipment, and resources are needed. And then carcass disposal depends on available logistic and field conditions. Why developing a stranding network? First of all, well-trained structure and coordinated stranding networks can achieve a lot of marine mammal conservation from little resources, both human, logistic, and financial. Of course, the first purpose is to be in capacity to return alive animals to the sea. But they also bring people together with trainings and fieldwork, which often results in development of collaborative projects to enhance species knowledge and conservation. Stranding networks are also often involve volunteers at several steps of the process, such as alert, data and sample collection, and communication. In that sense, it has all the virtues of citizen science, such as the education of a large public to conservation issues and building bridges between science and society. And of course, marine mammal stranding are often the main source of data and biological material to study these species and are essential to support scientific research and public conservation policies. Indeed, the data and samples collected allow to reinforce knowledge on the biology and ecology of the species, but also of the threats. For example, when no dedicated survey can be conducted at sea because of limited logistic and funding, strandings can provide a first estimate of species diversity in a region. For example, the analysis of stranded marine mammal signs along the Pacific and the Caribbean coast of Nicaragua from 2014 to 2021 have been provided the first description of the cetacean community in the country. Stranding networks can also provide information on the biology and ecology of species. For example, the analysis of stomach contents collected on stranded animals has allowed to study the diet and feeding ecology of various species all around the world, type of prey consumes, main foraging habitats, trophical level, trophical overlap, and potential competition with other species and fisheries. There are many examples of such studies in science literature. Histopathological analysis of tissues and organs from stranded animals can also help to identify natural causes of mortality, such as brucellosis. For example, cetacean brucellosis in Costa Rica was investigated from 2004 to 2016 and actually until now, and showed that the striped dolphin is highly susceptible to this disease and that many of the stranding events for this species in the country were due to brain infections, as recorded in other latitudes. Finally, data collected on stranded animals allow to identify anthropogenic causes of mortality. For example, in Venezuela, the review of cetacean stranding events from 1988 to 2014 showed that 36% of the stranding were due to interactions with fisheries, and 6% was the result of ship strikes. What data and samples can be collected? From external examination, one can report, for example, marks of collision with vessels or fishing nets or inter-intraspecific interactions or evidence of concussions, and of course, one can determine morphometric and sex. These data are very valuable to study, for example, mortality causes or length-age relationship. These are examples of external sampling. Teeth, you can have information of age and growth. Skin, you can make studies of genetics. And blubber, you can search for ecotoxicology information and diet. And here is an internal basis sampling. For example, if you collect brain, you can have information on pathogens. If you collect stomach, you can have information on diet, ecology, or foraging. If you collect kidney, we can have information of heavy metals. If you collect blood, we can have information of diseases. If we collect gonads, we can start to know the reproductive stage of the animal. If we collect liver, we can have information on persistent organic pollutants. And if we collect a pectoral fin, we can have an estimation of the age of the animal. So now we're going to talk about this long-term and wide-scale project. The first reasons for that is that in most cases, reaching an acceptable sample size to perform analysis can only be met after several years of data and sample acquisition. And in the case of a small island, this is often not enough, and collaboration have to be developed with other territories. We found an interesting example of that in the Philippines Stranding Network and how they started. The country of Philippines represents an archipelago of more than 7,000 islands and is divided in 64 coastal provinces. Stranding data were informally recorded in the country since 1999, and a formal national stranding network was created in 2005. But they waited until 2010 to perform their first review of strandings from 178 events recorded. This allowed to estimate for the first time the species diversity, most abundant species, and marine mammal hotspots. The first paper on studies performed from samples analysis were published 5 years later in 2015. Besides, only long-term data collection can highlight significant trends in ecological and biodemographic parameters and threats. For example, the continuous collection of stranding data along the French coast for over 40 years has highlighted recurring peaks of common dolphin strandings since the end of the 1980s on the Atlantic coast. The examination of these stranded animals show obvious signs of incidental bycatch in 75% of the cases. These results show evidence for the emergence of a major threat bycatch in fishing nets. In addition, some analyses are only valuable on a large scale, such as genetic and ecotoxicology. For example, in Brazil, the genetic analysis of samples collected on 2 humpback whales stranded along the Amazonian equatorial coast and their comparison with the haplotypes of other individuals have shown evidence that these animals belong to the species southern breeding stock A. This led to the hypothesis that the A stock is extending its range to the north or recolonizing its historical breeding areas. Finally, collaborations are essential to provide support for both logistic and expertise in case of an unusual event, such as the stranding of a large cetacean on a mass stranding. Wide-scale and long-term monitoring involves a high level of involvement, long-term commitment and sustainable fundings, coordination at various levels, including local, national, and regional, a minimal level of capacity and resources in each involved territories, consistency in data and samples collection and storage, networking tools including mailing lists, trainings, meetings, database, and common projects. So here we're going to talk about tips to develop a stranding network. Step 1. Take stock of the situation. And first, it is important to know the characteristics of the stranding in your territory. What is the stranded frequency? What are the main species involved? Are small cetaceans, are whales, or manatees? Are animals mainly dead or alive? What are the main known threats to marine mammals? Bycatch, acoustic disturbance, oil spill. How can you identify these threats on a stranded animal? According to the stranding characteristics, you can then list the required resources to develop or strengthen your network and identify which ones are available in your territory and which ones are lacking. So, of course, you need people, logistic, and funding. Regarding people, you need committed volunteers to alert and intervene on strandings. You may mobilize local organizations like NGOs or MPAs. You also need expertise with mammalogists and veterinarians to support the network in defining protocols and intervene when a live animal strands. Finally, it is also relevant to have in your network representative of local authorities. Regarding logistics, you will need sampling equipment, of course, but also carcass transportation means and equipment to store samples. Finally, don't forget to look for funding to develop and sustain the network and later perform data analysis. Don't forget that you are going to need resources to cover your whole territory. Finally, another recommendation is to identify projects and actions already implemented so that you can build on what is already exists. Start small. Establish a group in a small local area of coastline when you can achieve your organization goal successfully. Then expand that area as needed or as feasible. Regulation issues must also be looked at. Indeed, marine mammals are protected species in most Caribbean countries. As you can see in the map, about the half of the SPAW countries represented with blue EECs have a specific regulation for marine mammals. So you need to know what is allowed and forbidden regarding marine mammals in your territory, and what you need exemption for: manipulation, transport, collection, and storage of samples. Step 2. Define objectives and governance. First, in your network is going to involve several organizations. You may create a steering committee representative, of course, of the network members, volunteers, NGOs, research centers, MPAs, local authorities. Then the steering committee can, in accordance with step 1, define the objectives, priorities, and scope of the network. Depending on these objectives and scope, the governance of the network can be more or less complex and structured. Of course, things will be very different if your territory is a small island where the strandings are very rare, or a continental country with several hundreds of kilometers of coastal area, and many organizations involved in the network. So depending on all of that, you may nominate a network coordinator, ensure he is appropriate, trained, and familiar with response activities, define to which conditions organizations and people can become a member of the network. For example, do they need to attend a training? Do they need a legal authorization? Do they have to be a member of a local environment organization? However, be inclusive, as you may need many hands. You may also nominate who or which organization will be responsible for data and sample storage. You can also set up a legal status for the network. Finally, you can draft a charter to be signed by the network members with all these, but also procedures and protocols that we are going to see on the next slides. Coordinate closely with the local government to ensure that appropriate permissions are sought and granted, and help with the laboratory analysis, at least for some diseases. Coordinate with local collectivities and public services, city halls, firemen, and marine rescue. Step 3. Define procedures and protocols. This is very important to be able to professionally and quickly respond to strandings, to collect consistently data and samples, so that they can be used for knowledge enhancement and decision making, and to comply with legal framework. Examples of procedures and protocols are given in the corresponding presentation, and so I have just listed what you should not forget. Also, you will find several examples of standardized procedures, protocols, and field sheets in English, Spanish, and French on the CARIMAN website dedicated to strandings. So you have the address here and the QR code. First, it is recommended to define alert and post-response procedure. You can draft a call reception form with the information to be asked and to be given to the stranding reported. You may define areas of intervention with corresponding stranding network member contacts. You can define resources that should be mobilized for various stranding cases: unique individual, a live animal, mass stranding, stranding of a large cetaceans, animal distress at the sea, oil spill. Don't overlook unusual cases, as some may be very difficult to manage, so you have to be prepared. Finally, it may be relevant to list the contact of organizations outside the network that you should notify before and after the stranding response, such as local authorities, public services, and media. It is also recommended to mobilize, coordinate with and make contact lists of local organizations that may be of potential assistant veterinary offices for live animal response, police offices for public safety, public services for disposal of stranded cetaceans after the stranding response, organizations that have resources to intervene at the sea, fishermen, and whale watchers. You can draft a stranding reflex form for them. You may also make a contact list of regional expertise and potential field support in case of unusual events such as mass strandings. You will find such contacts on the CARIMAN website, the page dedicated to stranding contacts in the region, and you can also contact Michelle Deli or my person, Gabriela Hernández. We are members of the IWC Stranding Expert Panel, and we may have the information here in the last slide.
It is then important to define a protocol for data and sample collection from already available standardized protocols and in accordance with local specificities, species, threats, resources. Don't forget to clearly state who can intervene on strandings and what is allowed depending on the legal framework, and also to draft the corresponding field sheets for the network members. Another recommendation is that given that the level of response and capacity to respond to stranded differs according to the situation, it is often relevant to propose sampling protocols of different levels, from basic that may be conducted in all cases to complex protocols dedicated to experienced vets. It is also important to define protocols for data and sample storage. When relevant, you may create a database for data and samples, set up procedures to ensure sample traceability, such as labeling, and don't forget to nominate the organization in charge of the data and sample storage. You can also define a procedure for future data and sample exploitation projects, the conditions, who should be co-authors of the publications.
Safety is really important. Do not take unnecessary risk. Human safety is paramount in any response activity. Step 4. Enhance capacity. It is recommended to regularly organize stranding capacity building workshops for the technical response team. This training should include a stranding response in the various possible cases: unique dead animal, mass strandings, alive animal, and necropsy training should be also performed. Sample collection needs to a protocol should be described in detail, and along with safety issues. The training should be a combination of lectures and hands-off sessions.
Field training. Use emergencies or high-profile strandings to enhance capacity building. You may also have to buy the locking equipment for the different stranding cases: alive animal rescue, data and sample collection, transport and storage, and this for each area of intervention you have defined in your territory. Finally, you may need to look for funds for the network development, but also it's for long-term continuation. That is for the coordination to renew equipment and later to perform analysis.
Regional cooperation. Identify other partners regionally or internationally, or those individuals who may not be able to commit full-time to the network, but may be available on case-by-case basis. In a large-scale event, such as large whale or mass stranding, you will need to call on additional resources for help. Step 5. Communicate. First, of course, it is often relevant to set up networking tools to facilitate the communication between the network members, such as WhatsApp group, regular meeting, and mailing list.
In territories with long coastal areas, it is often difficult to be alerted each time a stranded animal is observed. So it is often relevant to enhance the network visibility in your territory, and not only towards the public, but also towards public services, NGO, etc. To do so, you may provide the network with a name, a logo, a telephone number, and email address, and you may create communication material such as flyers, posters, website, TV and radio spots, and t-shirts for the stranding team.
Finally, when you have enough data and samples and start thinking about their exploitation, it is important to enhance the network visibility at wider scale, notably to develop collaboration with research institutions. Step 6. Sustainability.
Finally, the issue of sustainability must be addressed. One of the greatest challenges a stranding network organization can face is developing a sustainable business model.
Raising money to build a sustained and stranding response network can be challenging. Non-profit organizations often depend on grants and donations to fund their activities, while government and agencies, universities, and aquaria may receive base operational funding from their parent organization. Whichever means are used to support the organization, it is important to plan ahead and develop strategies to secure ongoing funding and diversify revenue streams.
And here are all the references that we use to compile this information for you today.